All right, this video is going to talk about quadratic models, and you'll notice up top on our screen we have three different quadratic models we typically use. Y equals ax squared plus bx plus c. Now some books, typically Algebra 2 books, are going to talk about that as a standard form. In the pre-calc level, we would talk about it more as a basic or a simplified or an expanded form. Okay, expanded meaning we just multiplied it all, we simplified, right? Added all the like terms, but we don't have any extra parentheses, nothing else to combine, things like that. Vertex form, or what most pre-calc books would call standard form, is down here. So that's where, again, H and K are going to be our vertex. It's that sort of transformational idea. H moving us to the right or left, K moving us up or down, taking that origin, right, of a parent function, basic parent function of a quadratic, and moving the vertex from 0, 0 to H and K. And then A is, again, still sort of our vertical stretch idea. So this is much more of a transformational idea, and a very easy thing to use. That's why we call it standard or vertex form. It quickly gets you the vertex and that transformation, the stretches, the shrinks, the reflects. Intercept form down here is often called factored form. Again, we've got x minus p times x minus q, p and q being the x-intercepts, right? Technically, if we wrote it out, we would have two x-intercepts right now of p comma 0 and q comma 0, right? That are identified very quickly and easily from our equation, right? Which makes two easy points to find. That's why we like it. So down here at the bottom, we've got f of x equals, notice that x-intercept form, right? Or the intercept form of the equation, the factored form. So technically, if I was trying to find the x-intercepts, I would say right now that 5, 0, right? Because 5 would have made that first quantity into 0, and 0 times anything, 0 times the other quantity, that's going to stay 0. 5, 0 would be one of my x-intercepts. And again, with using the other one, if we plugged in -3, we'll quickly calculate 0. Well, that's not what the question's asking us right now. But again, that's why intercept form is fairly helpful right there. What we really want, though, right now is the expanded form. How do we make this into expanded form? And the easy part about that is all we really need to do is distribute, or if you're familiar with the word FOIL, basically I need to take x times both parts, right, of the other equation, and then I take -5 times both parts. Sorry, not equation, but of the other quantity here. So to find expanded form from intercept form, right, to convert back and forth, what we would need to do is, again, simply FOIL. X times x being x squared, x times positive 3 being a 3x. In the middle, we get a -5x. And then at the end, -5 times 3 is -15. And f of x, therefore, excuse the bell there, f of x, therefore, is going to be x squared plus a -2x. So actually, I'm going to go ahead and say minus 2x, right? We're going to add those two middle terms, minus 15. And again, that's how we can quickly find expanded form from intercept form. Now, it takes a little bit more work to get that all the way back to standard form, all the way to vertex form, but that would be our general method. Let's look at another example here. So if we start in intercept form, to get to vertex form, right, basically we have to go through our basic or our expanded form. So first thing we're going to do is go ahead and FOIL this out or distribute. So I'm going to take x times x is x squared. Again, on the outside, I'm going to have x times 10, and on the inside, -3 times x. So I've got a 10x and a 3x. I'm going to go ahead and jump straight to, we're going to have a 7x, and then finally, -3 times 10 would be -30. So again, that there is our basic, right, or our expanded form. To get all the way to vertex form, right, we want that form where we've got a in the front, but we've got x minus h squared plus k. Well, I need this perfect square in the middle. So this is where we're going to take advantage of that complete the square method. And what I'm going to do is say, okay, this is f of x. Now, I don't really want to mess with that. I want to keep f of x. So I'm going to leave that over here at the left. But I'm going to kind of quarantine. I'm going to kind of make this x squared plus 7x. And we're going to sort of ignore the -30, right? We're going to sort of isolate that inside the parentheses. Well, to make a perfect square, and we have to take half the middle. That's the perfect square method. So half of 7 would be 3.5, or 7 halves. Okay. And I'm going to imagine that, oops, got my squared in there. We don't want that, because that is going to be my perfect square binomial here, my perfect square quantity. Well, in order for that to happen, we have to have 3.5 squared inside of our parentheses, right? That makes this a perfect square trinomial. And if we had x squared, right, from the bottom here, we've got that up top. X times 3.5 times 2 always gives us the middle. And 3.5 squared would have given us the end. These two statements now inside the parentheses, these two things are equal to each other. But what I have to remember is if I add something to an equation, I either need to add it equivalently to the other side, or I can balance by saying, well, 3.5 squared, technically times a 1 in front here. There's nothing in front of the parentheses. So that's a 3.5 squared. If I added that, I can also subtract it. And that's kind of another way to go. Now what was in the parentheses again? Factors to x plus 3.5 squared. And negative 30 minus 3.5 squared is very simply going to be, give me 1 second here. Negative 30. Sorry, having a little bit of calculator issue. Which just means that's going to be a negative 42.5. Negative 42, sorry, 0.25. So that just became our function, which means if we're in vertex form, our vertex also just became negative 3.5, negative 42.25, right? There's h and k. There's my vertex. Again, sorry about the extra noises, sorry about a little bit of calculator issue. But again, hopefully that helps you remember how to complete the square, right? Take two parts, the x squared and the x to the first terms, convert that into a perfect square, and take advantage of that to make this vertex form. If you have any questions on that, talk to your teacher. Otherwise, this is part 2 of a 3-part video. You can also watch part 3. It's going to have a couple examples of how to also use vertex form very nicely to our advantage. So have a great day.